My dear first PU friends, I welcome all of you for the next session of first PUC Physics. The topic is units and dimensions. Already we did 2 sessions. In the first session we have understood what are units, basic units and all those things. The different systems of units. In the second session we move to dimensions, the powers with which these basic units are to be raised to obtain the derived units. We saw all those things. So then we wrote dimensional equations of different physical quantities. Then we gone to the uses of dimensional equations. So if you learn this, it is very useful to solve, to identify answers in CET, NEET exams. This plays a very important role. Some of the tricky questions can be solved, so if you learn these tactics. So under that, the first use is to convert one system of units to another system. So under that, yesterday we did 2 things. The next we shall move to convert Newton into dynes. So first you should know Newton is the SI unit of force. Dyne is the CGS unit of force. Both of them are, Newton and dynes are units of force. But Newton is the SI unit according to SI system. Dyne is the CGS unit. Okay? We know that the dimensional formula of force, this plays a very important role in the conversion. So force is given by mass into acceleration. There only, mass into acceleration, LT minus 2. MLT minus 2 is the dimensional formula of force. Things are very simple. It needs your involvement, make it very clear. Therefore, as Newton is the SI unit, we can write the unit of force, that is Newton, as, okay, this is mass. The SI unit of mass is kg power 1. The SI unit of length is meter. The SI unit of time is minus 2. The dimension is minus 2. This is 1. This is 1. Therefore, based on this dimensional formula, we can write 1 Newton as 1 kg meter second minus 2. Similarly, as dyne is the CGS unit, in CGS system, the unit of mass is gram. The unit of length is centimeter. The unit of time is second. CGS. That itself. Therefore, 1 dyne we can write like this. So, if we divide this by this, we can write kg, kilo, as 1000 grams, 10 to the power of 3 gram. 1 meter is nothing but 100 centimeter, that is 10 square centimeter, into second minus 2 divided by gram, centimeter, second minus 2. Gram goes, centimeter goes, second minus 2, power minus 2 goes. Therefore, we are left with 10 to the power of 3 into 10 to the power of 2. It is nothing but 10 to the power of 5 or 1 lakh. So therefore, if we cross multiply this, 1 Newton equals 10 to the power of 5 dynes or 1 lakh dynes. Newton, 1 lakh dynes make 1 Newton force. Again, so we will make you to understand all these things when we take up the next topic, that is Newton's laws of motion. After that, again we will define what is Newton, what is dyne, so and the relation between them. So learn how to use dimensional equations to convert one system of unit, that is SI system of unit, into CGS system of unit. Okay? Similarly, we can convert joule into ergs. I am changing the same thing, ergs. Okay? Make it very clear. Joule is the SI unit of work or energy. Erg is the CGS unit of work. The same thing. The dimensional formula of work is nothing but force into displacement. Therefore, one more L comes, it becomes L square. Okay? M L square T minus 2. Therefore, 1 joule equals, copy the same thing what you did earlier. 1 joule equals kg meter square second minus 2. Similarly, as erg is the CGS unit, 1 erg equals 1 gram centimeter square second minus 2. If I divide 1 joule by 1 erg, what I will get? So the same thing, kilo stands for 10 to the power of 3. This is meter. Meter is written as 10 to the power of 2 centimeter whole square. This is second minus 2. Gram centimeter square second minus 2. Therefore, this becomes 10 to the power of square whole square becomes 10 to the power of 4. This is 10 to the power of 3. It becomes 10 to the power of 7. Gram goes to gram, centimeter square goes to centimeter square, seconds minus 2, power minus 2 goes to second power minus 2. We are left with 10 to the power of 7. Therefore, 1 joule equals 10 to the power of 7 ergs. This is how we can convert one system of unit to another. These are the different uses of dimensional equations. Okay? Similarly, there are so many uses. So you know these things. If you know these things, you can apply the same thing to others also. Next, we shall move to the next use of dimensional equation, that is to check the correctness of physical equation. Read that statement once again. To check the correctness of physical equation. Whatever the equations that you get in physics, they should be, we can verify whether they are correct or not using dimensional equations. To check the correctness, there is one principle called principle of homogeneity of equations. The name itself says principle of homo. Homo means same. What is same? The dimensions of all the terms of the equation must be same. Then only the equation is correct. That means we can add, yes. So similarly we have the same thing in algebra. Okay? We can add like terms. Unlike terms can simply be written but cannot be added. The same thing is here. For an equation to be correct, the dimensions of all the terms of the equation must be same. We can add length to length. We can't add length to area. We can add displacement to displacement, velocity to velocity. We can't add velocity to acceleration. That is what this statement is saying. So the dimensional formula of left side and right side should be same. Then only the equation is correct. Otherwise, the equation is wrong. In physics, we didn't have such equations. All physical equations are dimensionally correct. They must be dimensionally correct. Okay. So let us take an example. Let us check the correctness of the equation, the very famous equation E equals mc square. E means energy, m means mass, c means speed of light, velocity of light in vacuum. So this is the relation between energy and mass. This is the highly significant equation given by the great ingenious scientist Albert Einstein. So the equation which relates energy and mass. So the relation between energy and mass is given by Albert Einstein. Let us verify that whether it is dimensionally correct or not. Okay? Yes. So let us take the left hand side. Dimension formula of left hand side, that is nothing but left hand side stands for energy. E means energy. The dimensional formula of energy is, in the last class we have seen, m L square T minus 2. Okay? This is the dimensional formula of left hand side. The right hand side we have only one term, that is m means mass, c means speed or velocity square. We have this much. This is the dimensional formula of RHS. The dimensional formula of mass is m. Velocity is Lt minus 1 whole square. Okay? If you simplify this further, so this is m power 1. Thus, if we apply laws of indices, L square T minus 2. Okay? Now you observe equation 1 and 2. The dimension of mass here is 1, here also 1. Here is 2, here also 2. Here is minus 2, here also minus 2. Therefore, dimensional formula of LHS is equal to the corresponding dimensions of RHS. According to the principle of homogeneity, all the terms have same dimensions. Therefore, the given equation is correct. So, if the dimension of this and this, any one of them is different, here too, if we have one here, the equation is wrong. Such equations doesn't exist in physics. Okay? So now let us move to the next example. Now I will take the equation V is equal to U plus AT square. Okay? You know the correct form of the equation already. So V is equal to U plus AT. This equation is wrong. Let us see how dimensionally we can verify. So V means final velocity. U means initial velocity. A stands for acceleration. T stands for time. Okay? Let us take the left hand side. Left hand side has only one term, that is velocity. The dimensional formula of velocity is Lt minus 1. So right hand side has two terms, binomial. The first term of RHS is velocity. Therefore, that dimensional formula is Lt minus 1. Therefore, this term have the same dimensions. The equation may be correct if we take these two things only. Let us move to the third term of the equation. The second term of the right hand side is AT square, that is acceleration into time square. The dimensional formula of acceleration is Lt minus 2. Time square, dimensional formula for time square is T square. If we simplify this further, this is L, base is same. If we add powers, minus 2 plus 2 becomes 0. Finally, we are left with length only. The time get cancelled. Therefore, if we observe equation 1, equation 2, equation 3, the dimension of length is 1. 1. What about the dimension of time? Minus 1. Here it is 0. Therefore, this term dimension is different from these two terms. Therefore, the dimensions of all the terms of the equation are not same. Though these two are same, but this is different. Therefore, the equation is not correct. For the equation to be correct, the dimension here also must be Lt minus 1. Therefore, the correct form of the equation we are going to derive in the next topic, that is V is equal to U plus AT is correct. AT square is wrong. This is how we can check whether the given equation is right or not. Okay? Using dimensional equations. This is a very important use of dimensional equations. You can check any equation. Take any equation. You can check it whether the equation is right or wrong. This application is very useful and advantageous to solve, to identify the answers in CET and NEET examinations, which option is correct. So it takes a very important role. Therefore, please learn this skill to check so whether the equation is right or wrong. So in the next session, we shall move to another application of dimensional analysis, that is to convert one system to derive the relation between the dependent quantities. We can derive the equation itself using dimensional analysis. That is one more use of dimensional equations we shall take up in the next session. So if you find any doubts, please send those doubts. I will get you clarified. So you collect the notes, go through all those things. So solve, read all those things. If you have any doubts, we shall clear in the next session. Thank you.